Today's lesson is about the seasons and what causes seasons. But before we can talk about the seasons, we first have to do a couple of vocabulary words about the movement of the sun. So let's start with these two words, rotation and revolution. These words are important because the way we use them in everyday life is sometimes slightly different from what is really happening scientifically. So rotation, who can tell me what does rotation mean in terms of the Earth's movement? Both of these are circular motions. It's okay, so let's take a look here. We have a lot of crazy answers. Rotation, you're rotating on an axis, and this is causing day and night. So if you think about the Earth, the best way to draw it is, here's the Earth. You can draw the axis through the north and south poles, and rotation on the axis is that it's turning this way. It's rotating on an axis. The best way to remember it is just remembering rotating on an axis. Okay? The second type of movement is revolution. Revolution is what type of motion? They're both circular motions. Yes, it's revolving around something else. So one object is moving around another object. So here we would have the sun, and then here's the Earth, and the Earth is revolving around the sun. And as you know, the Earth revolving around the sun, it is 1 year from here all the way around to come back to the same spot. So rotation, revolution. The words sound very similar, and the way we use them in everyday life is sometimes different than the scientific way. Make sure you know the difference between these two. I can guarantee you that on the quiz, there will be questions about these two, and which motion causes day and night, and which motion causes a year. All right, we will come to solstice and equinox in a minute, but we are going to skip those for now. So let's take all of these that we talk about today, or really make a lot more sense when you look at a picture. So let's look at a picture. So all of the planets, but the Earth, of course, is the one we care about right now. Here's the Earth's orbit around the sun, and the Earth rotating on its axis, the Earth revolving around the sun. So again, a good way to remember is by looking at it. And it's important that these two things are happening, and this combined with the tilt of the Earth is what is going to cause seasons. So as you saw in the video, and as you read about, and as you probably know, the Earth is not, the axis of rotation is not perpendicular. It is actually tilted. I believe it's 23 degrees. So instead of being straight up and down like this, it's tilted. And because of that, what's going to happen is how directly the sunlight hits the Earth changes. So when you're standing, or when the Earth is right here, and it's always hard to draw 3 dimensions in 2 dimensions, but is the sun hitting directly at the equator? No, the sun is hitting north or south of the equator? It's hitting south of the equator. So which hemisphere is having summer, north or south? The south. Because it's getting more direct sunlight. And on this side, it's kind of deflecting off a little bit more. Now, keep in mind, of course, that at the same time, the Earth is rotating on its axis, getting day and night. This is going to be night over here, of course. And this is daytime over here. Other planets do have seasons. After this week, as we talk about the sun, earth, and moon, and I think next week, we talk about the other planets. And the different planets have different seasons depending on how much they are tilted. So some have more extreme seasons and some have less extreme seasons. So then, and again, three-dimensionally, it's kind of hard to see, but when the Earth is here, the tilt is going along the way that it's moving here. So here, the sun is actually hitting directly at the equator. And so this would be either spring or summer. And then on this side, we've got the northern hemisphere getting the more direct rays. And then here is either fall. And if you, this is a picture, this is not a picture from the book, but so this says winter solstice, but of course to say winter, you have to say that it's winter in the northern hemisphere. And so then we have spring, summer, fall. Does that kind of make sense? Another way to think of this is, I'll come back to that. Another way to think of this is the sun is hitting more directly. It's similar thing as the sun rises and sets every day. What time of day is it usually warmest? In the middle of the day when the sun is directly over the head, because the sun is hitting more directly on you. That's the time of day you're more likely to get a sunburn, because the sun is hitting more directly on you. At the beginning of the day, when the sun is down near the horizon, it's not hitting as directly. Same thing in the evening. So it's a similar effect. Again, a common thing that people say is that it's warmer because the Earth is closer. Is the Earth closer to the sun in the summer? Well, what else is the problem with that? Is the entire Earth have summer at the same time? No. It's summer in the north and winter in the south, so it can't just be that it's closer. I think sometimes people understand, because this is more, they see this as being closer. It's not closer, it's just getting hit more directly. So I think sometimes you might understand it, but describe it wrong. So the reason there's seasons is because the Earth is tilted. Yes, so in December, in the southern hemisphere, it's warm. In Antarctica, the winter months are warmer. In Australia, December, Christmas, is in the summer. Isn't that weird? So in December, in Australia, in the southern parts of Africa and South America, it is warmer in December. I don't know if it snows in Australia, but if it did, it would snow in June and July. I don't know if they're far enough south for that. Okay, so then when you look at a diagram, because you will have to label a diagram of the seasons of the Earth going around in the year, how long does it take for the Earth to go around, to revolve around the sun one time? 365 days, 1 year, 12 months. No, 366 some years. So the easiest thing to do when you look at this picture is to first label winter and summer. And we talked before, because we just had, not too long ago, the winter solstice. What's the winter solstice? It's technically the first day of winter. The seasons are changing, right? And how did ancient peoples know that it was the winter solstice? What obvious thing did they notice about the days and nights? Yes. So this is the shortest day, longest night. Because what you can see, again, the Earth's axis is here, but this part right here is what's going to be in darkness, right? Ah. So, well, yeah, half the world is having nighttime. But look at this. How how much daylight are they getting at the South Pole right now? A lot. It's 24 hours of daylight. Look at that. It's always it would be really annoying, wouldn't it? And what about the North Pole? How much daylight are they getting in the winter? Zero. Right? You've heard of the land of the midnight sun. That's what they call. So here it is 24 hours. That's right. So at the extreme, at the North Pole and the South Pole, on the winter and summer solstice, for that small time of winter, they're getting 24 hours of light or 24 hours of dark. Okay? And then the same thing's going to happen over here. You should be drawing this, guys. Polar bears live in the North Pole. Penguins live in the South Pole. And then here, then we have the equinoxes. Solstice, sol means sun. Solstice is the shortest day and the longest night. And then over here, and that's of course for this is the winter solstice for the northern hemisphere. And then an equinox, as you might remember, equi means equal, nox means night. And so on the equinox, you have very close to equal hours of day and night, of light and dark. Equal night. So you've got the spring and the fall equinox. After the equinox, the days are longer than the nights. And so we had the winter solstice on December 22. So now our days are getting longer. You might notice, happily, that it's not quite as dark in the morning. It's not quite as dark as night. We're heading towards the equinox, and then we get to the summer. And of course, in the summer, it's awesome because it's light all the way till, 8 o'clock at night. It's light at 5 o'clock in the morning, so we have much longer days. That make sense? So you need to know solstice and equinox. And again, when you think of the extremes, that should make sense. So the same thing again. You've got the solstice and the equinox. And if it takes 12 months to go around the sun, and there's 4 seasons, each season is roughly how long? 3 months. Right? 1/4 of the way. All right, same thing. And so here we go. As you see this, go back to what? The definitions? Okay. Didn't write it down, did we? This one? Okay. All right, so go ahead and write those down. You definitely need to know these words. So for the lab tomorrow, for the quiz, for the unit test, you do need to make sure that, given a drawing, you can identify where is it summer, where is it winter. One thing people like to do is they look at the drawing, they say, oh, well, summer is, let's see, winter is on the right side of the drawing and summer's on the left side of the drawing. You cannot just go by the drawing because it has to do with how the sun's rays are hitting the earth. So you need to look at how the sun's rays are hitting. Usually, spring and fall are at the top and bottom of the diagram because that's the easiest way to show it. And then it's usually shown going counterclockwise. But you need to look and logically figure it out because then you know you will be right. So read over this and also read over your notes from yesterday. And this will all be repeated in your lab activity tomorrow.